Hello friends, this video on application of derivatives part 20 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 19. What is local maxima and minima? The first thing is local maxima and minima is defined only for open intervals. Correct? So I have told you first my critical point, the general formula of critical point or general critical points are: number 1, non-differentiable points, the points where the function is not differentiable, correct? Or endpoints or turning points. Now, in case of local maxima and minima, we know that we are talking about open intervals. Since we are talking about open intervals, endpoints are not in place. Since there is no question of endpoint, the critical points here can be either turning points or non-differentiable points. For example, if this is my function, correct? So I'll talk about the turning points where it can have local maxima and minima. Or if I have function like this, right? So in this case, if you see this point, it is not differentiable. It can have the maxima or minima at such points. Correct? So only 2 points, either non-differentiable points or turning point. So local maxima and minima can happen at 2 points, non-differentiable and turning points. Correct? Because local maxima and minima, we're talking about open interval, because there is no fixed intervals, right? This is all open intervals. So there's a theorem for local maxima and minima. It says that if f is a function defined in open interval, please note it's open interval. If c is a point, then if you see f as a local maxima or minima at x is equal to c if f dash c is 0 or f is not differentiable as t. I just showed you that if my c is a point of local maxima or minima, when I'm talking about open intervals, the c at c, either f dash c is equal to 0 or c or f is not differentiable at c. Either of these is true. That is, c is a considerable point for local maxima and minima. And that is what the theorem says. But please note the converse is not true. I'll explain that also, but just understand this guy first. So if you see, again I'll draw a similar kind of graph. So same thing, if my f dash c is, if you see all these places, f dash c is 0. These are the points I can consider for local maxima and minima. And one scenario is the same scenario I will take here like this. This is fx is equal to mod of x. This is not differentiable at 0. So this can also be a point of local maxima. But please note, the converse is not true. For example, if my function fx is equal to x cube, we plot like this. You find f dash x, this becomes 3x square, and you find f dash 0, that becomes 0, because 3 to 0, 0 square. F dash at a particular point c, that is c0, is 0, but this function need not have a maximum value or minimum value. If you see, the 0 point is not a maximum or minimum. Correct? So the converse is not true. So what I'm saying is, if c is local maxima or minima, f dash c has to be 0. But if f dash c is 0, it does not mean that c is local maxima or minima. It is not guaranteed. Correct? So that's why what we do, we just find all the values for f dash c is equal to 0 and just then actually find the value of c and check f dash c and check whether the value is maximum or minimum. Because there's a risk here. See, if c is max or min, then f dash c has to be 0. But if f dash c is equal to 0, c need not be max or min. It is not guaranteed, because some point, when you see f dash c, you get slope 0. Here also slope is 0 actually. Why? This kind of thing is called point of inflection. This is a very rare scenario actually. Mostly f dash c is equal to 0, that means it is a point of maximum. Very rare scenario is the point of inflection where the slope changes and this guy has slope of 0. This kind of point is called point of inflection, where f dash c is 0 but it is not maximum or minimum. Now we'll learn first derivative test to find maxima and minima. As we've already told, for local maxima and minima actually, if my f dash x is equal to 0 or it is non-differentiable, that guy is a local maxima or minima point. Since I'm talking about derivative test, so I'll not consider the non-differentiable part. I'll just consider this part. F dash x is equal to 0. That means the point is local maxima or minima. That is a turning point. The theorem says if f is a function in the open interval, please note the open interval here. Don't ignore this open interval, it's a critical thing because at the open interval only we're talking about local maxima and minima. And f is a continuous at a critical point. Critical point is all the point where f dash x is equal to 0. Then if f dash x change sign from positive to negative, if this guy is changing sign, right, then f dash x is greater than for every point close to and left of C, and this is less than 0 for right of C, then this point is called point of local maximum. See, why I'm trying to do this is, I know f dash x is equal to 0, then it is maximum or minimum, but we don't know whether it is maximum or minimum. To find whether the point C is, because f dash C is 0, but we don't know whether I'll say f dash C is 0, but we don't know the point C is maximum or minimum, right? Till now, with this I can say that it is a critical point, but I want to know its maximum or minimum. So using first derivative test only, we can find that. What they are trying to do is that they are trying to say that if my f dash x is increasing on the left, then this guy is called point of maxima, and if it is the other way around, it's called point of minima. And if it does not change, f dash x does not change, it is called point of inflection. Let's take the graph to understand this, else it's difficult for you. So this is a graph example. Now if you see, my point C is a point, critical point. C1 and C2 are my critical point. I got C1 and C2. Now I want to know whether my C1 is the point of local maximum or local minimum. Similarly, C2 is my point of local maximum or minimum. So what I'm doing is, I know my slope at this point is 0. I'll take one point which is just greater than C1. I'll find the slope. If the slope is negative, that means this curve is like this. I'll take one point just before C1 and find the slope. If the slope is positive, it is like this, correct? And this is like this. So if the slope is like this, I can make out that this is the graph is in this fashion. That means this point is the point of local maximum. See, don't learn these things which I told you now. It will be difficult to understand, right? Just observe this graph. This is the graph I have. In this graph, just see if it is maxima. If it is maxima like this guy slope is 0 at this point. You take any point here, the slope has to be negative, right? This is negative slope because the angle is between 90 and 180. If you take these points, it's a positive slope. Why? Because the angle is 0 and 90. So just before this, if the slope is positive, and just after this, if the slope is negative, it is of this kind of figure. In that case, I can say that this guy is point of local maximum. Other way around, if you see here also, if you see f dash C2 is 0, but if you take a point just after C2, the slope is positive, and just before C2, the slope is negative. So if you have this kind of figure, slope is 0, slope is negative, slope is positive, right? So in that case, you can see that this is the point of local And this is again, if you see, this is again a point which is non-differentiable. This is the point of non-differentiable. Non-differentiable point also can have a maximum or minimum. So all these points are here. Also I talk about point of inflection. If you see, this is my example, fx is equal to x cube. At this point 0, the slope is 0. And if you see, in this case, if you just go here, the slope is like this, that is positive. And if you go back also, it is positive. So in both the cases, if you go back or front, the slope is either always positive or negative. It doesn't change. Example, in this case, if you go front, the slope is negative. If you go back, the slope is positive. Here the other way around. If you go front, the slope is positive. If you go back, the slope is negative. But in this case, if you go back or front, the slope sign is not changing. In both cases, it is positive. So that kind of point is called point of inflection. Just understand this particular slide very carefully. It has almost most of the thing that you should know for maximum and minimum. Using first derivative test, if you see here, if you understood this clearly, the point at which we have maximum or minima, I have f dash c is 0. Just after this, it is less than 0. Just before this is greater than 0. So I get this kind of curves. That means this guy is a maximum. For this point, at this point, my f dash c is 0. Just after that, it is greater than 0 slope. And just before that, the slope is less than 0. So I get this kind of curve. That means it is point of minima. This is a point of non-differentiability where I don't have maximum or minima because these 2 points, if you see, are non-differentiable. So that can also have a maximum or minima, local maximum or minima. There is a point of inflection. This is one example where f dash x is 0, but even that it is not maximum or minima, because in that case, if you see, you go left or right, the slope is either always positive or negative. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.